Okay, a single phase transformer rated at 100 VA, 240 slash 12 volts, 50 Hz, has 120 turns on the secondary, and we have to calculate A, the primary current, B, the number of primary turns, and then C, the maximum value of flux. You are once again welcome to my channel, and before we start with the solution, please make sure you subscribe to the channel. Thank you so much. So we have a single phase transformer rated at 100 VA, 240 slash 12 volts, 50 Hz, has 120 turns on the secondary. Calculate the primary current, the number of primary turns, and then C, the maximum value of flux. Okay, so our solution A says we should calculate for the primary current. So our power is equal to IP times VP. The rated power is equal to IP times VP. So we have VA, which is the same as the rated power, is equal to IP times VP. So our IP is the primary current, and then the VP is the primary voltage, and then the VA is the rated what power. So to calculate for the primary current, which is the IP, we just make IP the subject. Okay, and we do that by dividing the rated power, which is VA, over the VP. Okay, so our IP, which is the primary current, is equal to VA over VP. That is the rated power over the primary voltage. So we have 100, which is the rated power, over 240, which is the primary voltage. So when you divide 100 by 240, our answer is going to be 0.42 amps, since we are calculating for current. Okay, so let's move on to the solution B. Solution B says we should calculate the number of primary turns. Okay, so we use the voltage transformation ratio. So we have NP over NS equals VP over VS. NP is the primary turns, NS is the secondary turns, and then VP is the primary voltage, VS is the secondary voltage. Okay, so the question says we should calculate the number of primary turns, which is what? NP. So we just transpose this formula to make NP the subject. Okay, and when we do that, our NP is going to be NS times VP over VS. NP equals NS times VP over VS. That is to calculate for the primary number of turns. We multiply the secondary number of turns by the primary voltage all over the secondary voltage. So we have 120 times 240 over 12. So when you multiply 120 by 240 over 12, our answer is going to be 2400 tens. I hope you are following it. So let's move on to the solution C. Solution C says we should calculate the maximum value of flags. So we use this formula: EP equals 4.44 times F, which is the frequency, times the flags, times NP, which is the primary number of tens. Okay, so here we have to make the maximum flags the subject of this formula. Okay, and when we do that, our maximum flags is going to be EP over 4.44, which is a constant value, times the frequency F, times the primary number of tens, which is NP. So our flags equals EP is what? 240 over 4.44 times the frequency, which is 50, times the primary number of tens that we have calculated, which is 2400. Okay, you divide 240 by 4.44 times 50 times 2400, and when you do that, our answer is going to be 0.00045, and the unit is in Weber. Okay, so our final answer is 0.00045 Weber. Thanks so much.